Okay, question 11. Find the integral of sine of 3x dx from 1 to 4 pi. So this would be 1 if whatever you have a trig function, we're going to let u be what's right next to it. So I'm going to let u equal 3x, and then du, the derivative of 3, would be 3 dx. Notice I have the dx, I'm missing the 3. So I'll put a 1/3 on the outside, and then I will have 1/3, and then I will now have the integral of sine of u du. And then from here, the integral of sine of u is negative cosine u, so I'll have negative 1/3 cosine of u. And then instead of putting plus c, I will get to evaluate it at 4 pi and 1. So let's see how we do here. I'm going to get negative 1/3 cosine. 4 pi times 3 is going to be 12 pi, and then minus negative 1/3 cosine of 1 times 3 is 3. Alrighty, so let's think about this here a minute. 12 pi, draw a unit circle, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi would be just around the unit circle 6 times. And if I go around the unit circle 6 times, the cosine value or the x value there would be 1. So this is going to be negative 1/3. Negative times a negative gives me a plus 1/3. I don't know what the cosine of 3 is, so I'm just going to leave it as the cosine of 3. The final thing that I can do on this one is factor out a 1/3. So I will get negative 1 plus the cosine of 3. And that will be my answer. Okay, 12. The normal monthly precipitation in Portland, Oregon can be approximated by the model R equals 2.880 plus 2.125 sine of 0.578t plus 0.745, where R is measured in inches and t in the time in months, with t equals 0 corresponding to January. Approximate the average monthly precipitation during the months of September and October. You may use your non-graphing calculator to help on this one, but we get to just tackle this one without our calculator today. So if we want an average monthly precipitation, the second I see the word average, I'm going to do 1 over b minus a times the integral from a to b of my function, and this function in this case happens to be r. So we're going to have 1 over, we just want to go from September to October, so we're just going to go from month 8 to month 9, so it will be 9 minus 8, and we'll go from 8 to 9, and then we'll put our function in there. So 2.880 plus 2.125 sine of 0.578t plus 0.745. Okay, so, and this will all be dt. All right, from here, kind of looks like a mess. The first thing that I'm going to do on this one, this would be just reduced to 1, just FYI. All right, since there is a plus sign, we can separate the integral into 2 parts. So it's going to be 2.880 plus 2.125 sine of 0.578t plus 0.745. Alrighty, from here, one thing I'm going to do, because that 2.125 is just kind of messy, I'm just going to pull it out front for right now, so 2.125. Alrighty. Okay, from here, what we would like to do is on this one, the integral of 2.880 is just going to be 2.880t. On this one, as soon as you see a sign, we're always going to let u be what's right next to it. So we're going to let u equal 0.578t plus 0.745, which means if I take the derivative of that, the derivative of 0.578t is 0.578. And I notice that I do not have 0.578 there, so I'm going to multiply by 0.578 on the inside, which means I have to divide by 0.578 on the outside. So I am going to now get, and then this will just turn into 2.125 over 0.578, and then this is now the integral of sine of u, and the integral of sine of u is negative cosine of u, so this is going to be minus 2.125 over 0.578 cosine of u, and cosine happens to be 0.578t plus 0.745, and then this first part I'm just going to bring down 2.880t. I'm not going to put plus c because I want to evaluate it at 9 and at 8. So basically what I'm going to be doing now is I'm going to plug in 9 for all parts of this answer, and if I plug in 9 for all parts of that answer, I'll get 22.449, and then minus, if I plug 8 into both parts of that answer, I will get 20.745. 7987. And then if I subtract those two, I will get 1.654. So what on earth did I just find? Let's see. So it asked me to find the average monthly precipitation. So precipitation is measured in inches. So the average monthly precipitation in Portland, Oregon in the months of September, October is 1.654 inches. All right, number 13. The acceleration of a particle moving along the x-axis is a of t equals 3 plus 4t meters per second squared. At time equals 0, the velocity is 1. And it says to find an equation for the velocity. So I'm at acceleration. I need to get to velocity, which means I need to go back a step. So to get to velocity, we're going to take the integral of the acceleration. So I'm going to take the integral of 3 plus 4t. Since there's a plus sign, we can take the integral of both parts separately. So we're going to get the velocity is equal to 3t plus 2t squared. And don't forget we have to put the plus c. Now I'm going to use the information at time equals 0, the velocity is 1. So when t equals 0, the velocity is equal to 1. So that's going to give me that c is equal to 1. So my equation for velocity is going to be v equals 3t plus 2t squared plus 1. All right, and then it says how far does the particle move during the first second of its trip from t equals 0 to t equals 1. So if I want to know how far the particle moves, that would be distance traveled. And we know the formula for distance traveled is the integral from a to b, so from 0 to 1, of the absolute value of velocity. So if I find the absolute value of velocity here, it's going to be 0 to 1. The absolute value of velocity, we just found out that the velocity is 3t plus 2t squared plus 1. And we don't get to use our calculator on this one, so we usually split this where this equals 0. I know if I'm going from 0 to 1, anywhere between 0 and 1, this is not going to equal 0. If I plug in 0 anywhere to plug in 1, there's no way that I'm going to get something that equals 0. So on this specific problem, we do not actually have to use the absolute values. We can just be good with just parentheses. And since there's a plus sign, we can go ahead and take each part separately. So that is what I'm going to do next. And then if I do that, the integral of 3t will be 3/2 t squared, plus the integral of 2t squared will be 2/3 t cubed, and then plus the integral of 1 will be t. And then I get to evaluate it at 1 and 0. And looks like we're going to have fun with some fractions here. So if I plug in 1, I'm going to get 3/2 plus 2/3 plus 1. And then if I plug in 0, I'll just get minus 0. And then I think I'll get a common denominator here. I'll make them all 6. So this would be 9/6, this will be 4/6, and this will be 6/6. And if I add those all together, I will get 19/6. So that's how far, and it's actually, if it says how far does the particle move, it will be 19/6 meters. And there we go. Right, problem 14, find the integral of secant squared x from 0 to pi over 4. All right, this one is totally formula recognition. Hopefully you are now well aware that the integral of secant squared is tangent x, and now we just get to evaluate it at pi over 4 and 0. So we're going to have tangent of pi over 4 minus the tangent of 0. And for both of these, it's going to be sine of pi over 4 over the cosine of pi over 4. And then this one will be sine of 0 over cosine of 0. Okay, the sine of pi over 4 is the square root of 2 over 2. The cosine of pi over 4 is also the square root of 2 over 2. So this whole thing will be 1. And then minus the sine of 0 is 0. The cosine of 0 is 1. 0 divided by 1 is 0. So 1 minus 0 is 1. All right, problem 15. Using the substitution u equals 3x minus 4, this expression is equivalent to which one down below. So basically they're asking us to do a u substitution. So I'm going to go ahead and get us set up for that. So if we let u equal 3x minus 4, we need to identify our du. The derivative of 3x minus 4 is 3, which means we'd have to put a 3 on the inside and a 1/3 on the outside. So I'm going to have 1/3 the integral. And we would now have the square root of u du. One thing that I need to check now are these values, this 1 and the 7. Remember, those are x values. And if we have u's in my problem now, we do need to change those to u's. So I'm going to put u equals, and we know that u equals 3x minus 4. So when x equals 1, my u is going to equal 3 times 1 minus 4, which is -1. And then when x equals 7, I'm going to get u equals 3 times 7 minus 4, and that will equal 17. So my limits need to go from -1 to 17. So if I look at which matches that, it would be choice B. And there we go.